Hi, everyone. Welcome to our final session of the Great Lakes Coastal Wetlands webinar series hosted by Environment and Climate Change Canada and Toronto and Region Conservation Authority. My name is Sharon Lam, and it is my pleasure to moderate today's webinar. I'm a project manager with the Ecosystem and Climate Science team at Toronto and Region Conservation Authority, and I'm joined by an amazing group of colleagues in both ECCC and TRCA, some of whom you'll meet over the course of this afternoon. Let me begin by taking a moment to respectfully acknowledge that all of us at this virtual meeting, no matter where we are located on land that has been home to Indigenous nations since time immemorial. We respectfully acknowledge that the lands we are situated on are traditional territories and treaty lands, in particular those of the Mississaugas of the Credit, the Anishinaabe of the Williams Treaty First Nations, the Huron-Wendat, the Haudenosaunee, and are now home to many diverse First Nations, Inuit, and Métis peoples. We appreciate and respect the history and diversity of the land and are grateful to have the opportunity to work and meet in this territory. And we are honored to be joined by representatives of Indigenous organizations at today's webinar and at our previous sessions as well. Let's now go over some quick housekeeping notes. Today's session is being recorded, and a copy of the recording and slides will be shared with all of you in a couple of weeks following the completion of the webinar series. All participants are muted and video disabled to minimize disruption and save bandwidth and emissions. Please use the Q&A box at the bottom of your Zoom control panel to post questions throughout today's session. You can also upvote others' questions in the Q&A. To share comments, please use the chat, and thank you to all of you for sharing with us in the chat your name and where you're calling from today. As always, it's great to see some familiar names. Closed captioning is available in English, and you can enable or disable this by clicking the CC icon at the bottom of your Zoom control panel. If you encounter any technical issues with Zoom, please send an email to Jessica for support. And with that, let's now take a look at what we have already covered over the course of this week-long 5-part webinar series. The first 2 webinars on Monday and Tuesday focused on the results of Environment and Climate Change Canada's Great Lakes Coastal Wetlands Climate Change Vulnerability Assessment. Session 1 focused on the results of the Climate, Lake Level, and Wetland Response Modeling developed by Environment and Climate Change Canada, and Session 2 focused on the remaining results from the vulnerability assessment, including wetland sensitivity, adaptive capacity, and overall vulnerability. Over the course of sessions 3 to 5 from Wednesday onwards, we have been exploring different climate change adaptation strategies and options to enhance the resilience of Great Lakes coastal wetlands with guest speakers from across the Great Lakes Basin. And today's final session will focus on identifying climate refugia and advancing wetland conservation and protection. If you missed previous sessions, we do hope that you'll check out the recordings once they are available in a couple of weeks. Through these webinars, we hope to engage coastal wetland practitioners, describe Environment and Climate Change Canada's vulnerability assessment, modeling, and analysis, share the results of the climate and water level projections, wetland sensitivity, adaptive capacity, and vulnerability, and explore best adaptation strategies and options to enhance coastal wetland resilience, which we will continue to do today. And with that, let's take a closer look at what we have in store for you today. We will begin with a presentation by Greg Mayne and Anders Holder, who will provide an overview of Environment and Climate Change Canada's white paper on solutions to enhance Great Lakes coastal wetland resilience, which was prepared as part of the Assessing and Enhancing the Resilience of Great Lakes Coastal Wetlands project. Greg and Anders' presentation will help set the stage for our 3 guest presentations today, starting with Scott Parker from Parks Canada, who will be speaking with us about coastal wetlands in a protected areas context. We will then take a quick 5-minute break and come back for our last set of presentations and hear from Robin Rumney and Dan Kraus from the Wildlife Conservation Society Canada, who will speak about identifying key biodiversity areas to support Great Lakes coastal wetland conservation. Last but not least, we will hear from Kristen Bernard on Nature Conservancy of Canada's Great Lakes Conservation. And there should be ample time for questions after each of the presentations today. And we'll also have a collective panel discussion at the end. So please input your questions in the Q&A throughout the presentations, and where possible, please address your questions to specific speakers. I will now invite Greg to share his screen while I provide a brief introduction. Greg Mayne is the Habitat and Species Unit Head with Environment and Climate Change Canada's Great Lakes Ecosystem Management section. Greg began his career as a biologist with the province and later as wildlife toxicologist with the Canadian Wildlife Service. And since 2004, Greg has co-developed various Great Lakes plans, including lake-wide action and management plans, biodiversity action strategies, baseline coastal habitat surveys, initiatives for community-based action, and most recently on coastal wetland vulnerability, resilience, and adaptation. And Greg, I see that your presentation is now up and in full presentation mode, so I'll pass the floor now to you.
Thanks for that introduction, Sharon. Good afternoon and welcome everyone. Welcome back. It's been a long week, but a really gratifying week, I must say. It's been fantastic. My presentation today will briefly recap what we learned over the course of this week, and then I'll transition to some thoughts on resilience and adaptation. I'll introduce a new paper on solutions for enhancing coastal wetland resilience so that we can continue our conversation about coastal wetland adaptation that we started on Wednesday and yesterday. Finally, I'll introduce our last two strategies before handing it over to our speakers so that they can help bring them to life through their work and conservation experience. A few years ago, we set out to answer some basic questions on this slide that show the three basic dimensions of climate resilience. And we shared our understanding throughout our webinar session this week. First, we shared new information on climate and lake level projections to understand potential coastal wetland exposure to future climate and lake levels. Secondly, we shared plausible coastal wetland responses, sensitivities, adaptive capacity, and overall vulnerability to climate change. And lastly, we introduced how we can enhance coastal wetland resilience through several adaptation strategies and measures. Many of these approaches are probably familiar to you, but what we've done is to put them all in one document for, I guess, easy digestion. We'll continue that discussion today. So this slide really captures the dimensions of resilience thinking, from what is it that we should be resilient to, the resilient of what in terms of its vulnerability, and how should we approach enhancing wetland resilience. There should be no lingering doubts after the course of this week that climate change is impacting the Great Lakes and coastal wetlands. Ice cover is decreasing across the Great Lakes that otherwise protect shorelines from erosion. Air and water temperatures are warming, and there are more frequent and extreme storm events that result in runoff and water quality issues. Record-breaking high and low lake levels have occurred in the span of just a few short years, and these are just some of the signs of what may come. Frank Suglenieks from the Meteorological Service of Canada shared new climate and lake level projections on Monday. And this slide shows an example for Lake Erie under the intermediate and high emission scenarios as just an example. Of course, all of this information is available in a report that will be available to you at the finality of our project. So just to recap what we've already discussed, annual and seasonal air temperatures are projected to increase across the basin compared to the baseline period that's outlined in the hashed line. Annual precipitation will also likely increase, and in all seasons, although the increase is generally less in the summer. The darker shaded areas on this slide reflect the worst case emission scenario. That is representative concentration pathway 8.5. That's the status quo scenario. And the lighter color is a projection using the intermediate greenhouse gas scenario, which peaks around 2040 and then starts to decline around 2045. And it's called representative representative concentration pathway 4.5. So ice cover, while not a part of the study, is expected to continue across all Great Lakes under the high emission scenario. Average ice cover over Lakes Superior and Erie show the greatest projected declines relative to other lakes. And of course, of most importance to coastal wetland managers is that lake levels are projected to increase in variability with even more extreme highs and lows possible. Again, shown by the darker green shaded color, which represents the higher lake level scenario, and the blue colored, the blue shaded area, representing the low, or RCP 4.5. We saw a slide similar to this one throughout the week on what's at stake for the Great Lakes. Coastal wetlands are essential to the Great Lakes ecosystem for many reasons, and most of which you know. I'm preaching to the choir here. Defense against erosion and watershed pollutants rank among one of the most important functions of coastal wetlands. Habitat for a diversity of plants, birds, amphibians, fishes, and wildlife. And we provided numbers to those various species earlier on this week. And wetlands are known for their cultural significance and the recreational opportunities that they provide. Of importance to the Great Lakes and the Great Lakes Water Quality Agreement is that wetlands, including coastal marshes and fens, provided billions of dollars in terms of water purification services annually. And this paper is just one of several papers that examines the potential for sediment and phosphorus filtration in Southern Ontario. Given the importance of wetlands and the climate change risks that they face, we shared the results of a coastal wetland vulnerability assessment this week. You now can appreciate the comprehensive modeling effort that provided us with some insight into future climate change exposure and how this information was integrated into a coastal wetland response model and used to determine wetland sensitivity and the potential impact of coastal wetlands to climate change. You learn about how we combine these results with a spatial analysis of adaptive capacity. That's the current condition of coastal wetlands based on land cover and land use protection and potential for wetland migration. All of this was integrated to understand coastal wetland vulnerability. Recall that we shared a number of Canadian study sites from across the Great Lakes, but in the end, we assessed wetland vulnerability at 20 of these sites shown on the map. We included wetlands of different hydrogeomorphic types, sites found within a gradient of land cover and land use intensity, wetlands on private and public lands, wetlands within provincial and national parks, and within national wildlife management areas, as well as sites of cultural significance located on First Nations lands. The Meteorological Service of Canada shared excellent information on how they developed the coastal wetland response model and how this powerful tool consists of several standalone products for each of the 20 coastal wetland sites. Along with the high-resolution digital elevation models shown on the right-hand side of this slide, the outputs included high-quality results and visualizations on simulated changes to 4 to 5 different wetland vegetation community classes over time. For example, this slide shows changes at Rondeau Bay on northern Lake Erie under the upper bound lake level scenario. It shows a greater loss of submergent aquatic vegetation than a gain, and a gain of marsh habitat at the expense of swamp. This is just one of 20 examples, and we have many more visualizations available. The model also provides insight into possible wetland area gains and losses shown on this slide. This under future climate scenarios, RCP 4.5 or the intermediate scenario, and bounded by upper bounds, that is higher lake levels, as well as lower bounds, and that is lower lake level scenarios. So you can see here that there are a number of changes to total wetland area. And in particular, you can see for Lake Erie and Lake St. Clair in the center of this slide, that we are indeed expecting some losses based on projected changes of climate and lake levels. This information was integrated into a sensitivity analysis presented by Greg Gravis from the Canadian Wildlife Service on Tuesday. And his work reveals that all wetland study sites are sensitive to climate-induced lake level changes, but to various degrees. On this slide, you can see that some wetland sites had an overall lower sensitivity or risk in the green shaded area, but for the most part, the majority of the wetlands studied are at high risk in the yellow area. And even several of the wetlands were ranked as at critical risk, and that's shown in the bars and dots extending into the red colored area of this slide. This slide shows that wetland sites with the lowest adaptive capacity were located in the Lake St. Clair area, Detroit River, Western Lake Erie, and to a certain extent, Western Lake Ontario. And Morgan Rennick from the Wildlife Landscape Science Directorate provided an explanation in her talk on Tuesday, including all of these metrics, how they were chosen, how they were spatially analyzed, and combine to produce this map output. Again, these reports will be made available. And finally, Patrick Rivers, who was one of my staff but has moved back to the Canadian Wildlife Service, explained the integration of information and the overall vulnerability for each wetland study site under the intermediate emission scenario. And for specifically lower bound water level scenarios shown on the left-hand side of each circle, and the upper bound or higher water level scenario shown on the right-hand side of this circle, or each circle. Vulnerability ranges from very low to very high, and this is illustrated by the green, yellow, orange, red, and dark red or crimson colors, with green being the lowest in vulnerability and dark red or crimson being the highest in vulnerability. So in general, we found that wetland vulnerability differs across the Great Lakes. Wetlands are indeed vulnerable to projected climate change, and especially under the upper bound scenario with projections for higher lake levels. We also see a cluster of highly vulnerable wetlands in Western Lake Erie, Eastern Lake St. Clair, and Western Lake Ontario. But note that all wetlands are vulnerable to a certain degree and can use adaptation measures, which we'll discuss today. I realize this is rather quick, but I hope that many of you have seen these slides earlier on this week. So as an extra bonus, yesterday, our partners from the Meteorological Service of Canada completed an equally intensive modeling exercise that examined population growth and suitable habitat for invasive typha and Phragmites under future possible lake level changes. Highlights of that work include, and I'm going to really skim the surface, is that all wetlands are threatened by both invasive species. Climate change will play a role in the expansion, but it's really site-specific, depending on local conditions. In some cases, like Rondeau Bay, shown in this slide, climate change doesn't really increase suitable habitat for Phragmites, but its expansion is primarily caused by the inherent exponential growth capability of this species. In other areas, low water levels likely favor Phragmites growth in all lakes except in Lake Ontario, where typha will continue to dominate. High water levels reduce the growth and suitable habitat of both species in Lake St. Clair, and on Lake Huron, wetland sites generally appear less vulnerable to Phragmites and typha, although we all know they exist there and work is being done to eradicate them. It appears through the modeling that it's a little less vulnerable. This takes us to a paper that we completed as part of the study called Adapting to Climate Change: Solutions for Coastal Wetland Resilience. The work is framed as an entry point for adaptation and should be viewed as the beginning of a much longer conversation. It really is intended for resource management agencies, conservation authorities, policymakers and planners, NGOs, Indigenous communities, industry, and landowners, all with a stake in coastal wetland resilience and conservation. The paper provides background on coastal wetlands, the benefits to society that they provide, climate and lake level projections, and of course, impacts of climate as well as non-climate stressors. It also introduces resilience thinking and some of the principles and preconditions of resilient wetlands. Developing a suite of key adaptation strategies involved several authors shown in this slide. It began with your input through workshops and interviews. It included a comprehensive literature review and synthesis, plus insight from a multi-agency advisory committee who we met with over the course of last year and into the year before sending it out for broad review to many of you. The paper is largely based on accepted principles and preconditions found in published papers and books for resilience and adaptation. These are just a few points that should be familiar to many of you working in conservation. Collectively, they help us move from theory to practice. And just to summarize, we really should be considering several points when we want to enhance wetland resilience through adaptation. So I'm just going to briefly touch on these. The ecological and geological setting has to be considered, as well as the social, cultural, political, and economic dynamics at a site or a region within the Great Lakes. Working at the appropriate scale and identifying and protecting key patterns and processes that operate within a wetland or within the catchment or the shoreline and the coastal compartment that contains a complete cycle of sedimentation, including sources, transport, paths, and sinks. Ensuring connectivity of wetlands to the lakes, rivers, and other adjacent aquatic and terrestrial habitats is key. Maintaining and improving structural complexity, diversity, and functional redundancy, which we spoke about yesterday. Maintain, as mentioned also, adaptation is about proper governance and well-connected people, institutions, and partnerships across jurisdictions. And above all, we have to avoid negative impacts when we implement adaptation projects, and we advocate the use of an adaptive management approach. You can use the resilience principles in your own work, and the results of our vulnerability assessment can be teased apart for each coastal wetland site to help inform adaptation. Here you can see the breakdown of wetland sensitivity and adaptive capacity for Rondeau Bay and Lake Erie. Given the potential for wetland loss and risks associated with altered sediment supply, you can select adaptation options from the resilience paper that I mentioned. And one option might be to reestablish sediment transport by bypassing sand trapped at a downdrift jetty that Pete Suzak pointed out the other day. Coastal wetlands also must have accommodation space as they transition upward or upland towards the upland area, as well as downland or downward into the water through their hydrological gradient. So local municipal planners and conservation groups can map these potential pathways to climate refugial areas under high lake level scenarios, protect them from development, and enhance them. One last point I want to highlight is that development of a menu of adaptation strategies and options for the broader Great Lakes coastal ecosystem incorporates other work out there. On the screen, I'm showing the title page of a piece of work that was developed by a multi-agency initiative led by the Northern Institute of Applied Climate Science, or NIACS, and supported by the Great Lakes Water Quality Agreement and the Habitat and Species Annex, particularly the U.S. Fish and Wildlife Service. It includes coastal wetlands, but summarizes needs for other habitat types along the coastline that are directly affected by climate change impacts. So practitioners can strengthen their long-term plans through proactive and intentional consideration of climate changes, and by selecting from this adaptation menu, but the adaptation menu that that we're explaining today and yesterday or the day before on coastal wetlands. So we introduced 4 adaptation strategies on Wednesday as well as yesterday. I'll now turn it over to Anders Holder, who works with me to introduce our last 2 strategies before we ask our invited speakers to share their knowledge and experience.
Good afternoon, everyone. So today I'll be introducing adaptation strategies 5 and 6, which will be found in the report that Greg highlighted, Adapting to Climate Change, Solutions to Enhance Great Lakes Coastal Wetland Resilience. In the interest of time, I will briefly touch upon both strategies and select measures that will complement our presenters. Strategy 5 focuses on identifying, managing, creating, and protecting future wetland refugia based on the current climate change scenarios. So what is climate change refugia? Climate change refugia are areas in which a population of organisms and habitats are provided a safe haven during periods of unfavorable climate conditions and serve as sources for colonization of following climate disturbance. The key attribute of refugia is their relative persistence, despite changes in the climate in the surrounding landscape. Managing climate change refugia allows for both the local ecosystem to adapt and for conservation planners and managers to develop longer-term solutions. Similar to an adaptive management cycle, the climate change refugia conservation cycle provides a framework in 7 steps for managers to evaluate the value of refugia, identify refugia, and implement climate change refugial management. In addition to this conservation cycle, 2 key adaptive measures associated with Strategy 5 were developed: identifying and managing refugia retreat areas, and protecting groundwater sources, processes, and refugia. So why is this strategy important? Agriculture, urban, rural, and shoreline development, combined with the climate-induced drying and inundation, reduces the quality and availability of habitat for wetland flora and fauna. As described in Strategy 1, long-term management of wetlands is required to ensure that water quality, hydrologic connections, and the coastal processes operate at a scale within and outside of wetlands. Establishing climate change refugia is a promising adaptation measure that enhances wetland resilience and safeguards the ecosystem services that they provide. There is a need for a strategic approach to identify refugia at broad coastal scales, specifically that are projected to experience less severe climate and development changes, contain a diversity of physical and topographic features, and are projected to retain or remain with suitable climate conditions. Ensuring the availability of land for migration into upslope areas and protecting nearshore physical and biological conditions for downslope migration are important adaptive measures. As lake level fluctuations are expected to increase, wetland plant communities can transition provided that the land is available for wetlands to form during sustained high and low lake levels. This measure presents options to identify and manage refugia retreat areas. Examples of adaptation options include using GIS and other tools to map potential wetland migration, refugia, and retreat areas, integrate spatial planning overlays of refugia retreat areas at early land use planning stages to identify and protect areas that were naturally resilient to climate change to serve as refugia and provide opportunities for range shifts. And as well, removing where feasible, shoreline armoring, riprap, and other obstructions that prevent upslope wetland migration to suitable retreat areas. While mapping potential climate change refugia has advanced, challenges remain in identifying refugia at finer scales relevant to local land management, ground truthing, and mobilizing resources to ensure refugia are protected over time. Using the results of the wetland migration models presented earlier this week, we can see where prospective refugia may be located in Lane Creek Marsh, based on both the lower bound scenario and the upper bound scenario. And as you can see, there are areas inland that may provide suitable refugia areas. Groundwater structures and processes that link to surface discharge areas, such as springs, help maintain cooler water temperatures within and around fens, stabilize the seasonal variation of water levels within coastal fens, and play an important role in maintaining cooler water temperatures in streams and supporting cold water refugia during summer and warm water refugia in the winter. Sensitive groundwater fed fens are under threat from road development, drainage, erosion, and pollution. This map shows a summary of fens along Georgian Bay between Point O'Barrow and the French River using the results of the Canadian Great Lakes Baseline Coastal Habitat Survey. The protection of groundwater sources that provide refugia is important for coastal fens. And this measure presents adaptation approaches that identify and protect groundwater source areas as climate refugia sites. Examples of adaptation options include using GIS and other tools to map fens and mineral-rich groundwater sources for fens, protect fens from pollution, drainage, and other alterations in hydrology to maintain the chemical characteristics, and avoid road construction through fens to prevent hydrologic alterations and change in species composition and structure. The final adaptation strategy in this paper focuses on the need to improve Great Lakes coastal wetland conservation and protection, the focus of the presentations this afternoon. And while there's no unequivocal value for the percentage of land and water that should be protected, a review of scientific evidence for large-scale percentage area conservation targets indicate that at least 30% or even higher of land and sea should be protected. Using the results of the Canadian Great Lakes Baseline Coastal Habitat Survey and the data from the Canadian Protected and Conserved database, 14% of the entire coastal margin from Lake Huron to Lake Ontario is designated as protected or conserved land. However, 86% of all this protection occurs only within Lake Huron. And while coastal wetlands receive direct protection through national and provincial parks and indirect protection through a variety of policies, the existing network of protected areas may not be sufficient to allow wetlands and wetland-dependent organisms to adapt, transition, or be resilient to change in climatic conditions. Even within protected areas, adaptation actions are required to address climatic impacts. Coastal wetland resilience cannot be achieved without effective conservation measures that include protecting existing wetland areas and riparian corridors, minimizing further damage, restoring, enhancing, or reestablishing wetland area and function, and maintaining and reestablishing the ecological connectivity. Protected areas that include coastal wetlands play a crucial role in conserving biodiversity, enhancing climate resilience, and maintaining the ecological functions that generate these ecosystem services. So why is this strategy important? Using the results of the Canadian Great Lakes Baseline Coastal Habitat Survey and the Canadian Protected and Conserved Database, we can see that 5.5% of all coastal wetlands within Lake Huron to Lake Ontario is designated as protected or conserved. 64% of all these protected coastal wetlands occur within Lake Erie. And there is a need to increase the amount of protection afforded to coastal wetlands and their surrounding habitats. Protecting and conserving additional coastal wetland habitats reduces urban heat island effects, adds to refugia for native species, increases carbon sequestration, and enhances adaptive capacity and the coastal resilience, while also ensuring the delivery of ecosystem goods and services. This strategy provides several adaptation options to improve Great Lakes coastal wetland conservation and protection, including developing a standardized methodology to map and report coastal wetland areas, identifying opportunities to improve and modernize coastal and inland wetland conservation and management, and protecting additional coastal wetlands, adjacent habitat, and riparian corridors through conservation easements, land acquisitions, and conservation partnerships. An example of conservation and protection is a recent proposed land acquisition in Wesleyville, Ontario, located about 100 kilometers east of Toronto. In February, the Port Hope Municipal Council voted to proceed with the purchase of over 1,300 acres of land from the Ontario Power Generation. The land includes 4 kilometers of Lake Ontario shoreline. The proposed plan would include more than 50% of the lands available for parks, recreation, green space, and the protection of significant natural and cultural features. The purchase also aligns with community priorities and elements of Port Hope's strategic plan, including environmental recreation, natural heritage protection, and intentional growth in a stronger economy. Using the information provided from the Great Lakes Canadian Baseline Coastal Habitat Survey, we can see the diversity of wetland habitats within and surrounding this Barrier Beach coastal wetland lagoon. This acquisition has the potential to protect coastal wetlands, adjacent habitat, and riparian corridors. And while the entire property is not being protected, the addition of approximately 700 acres would increase the total protection of Lake Ontario's coastal margin by about 4.5%. Thank you for your time, and I'll now pass it back to Sharon.
Wonderful. Thanks, Greg and Anders, for the great recap of the week and overview of strategies 5 and 6, which helps set the stage for our 3 guest presenters today. I will now invite Scott to join us. I will be saving questions for Greg for the panel discussion at the end. So if you do have any questions for Greg, please input them in the Q&A. So Scott, please go ahead and share your screen while I provide a brief introduction. Dr. Scott Parker is the Great Lakes Regional Coordinator of Parks Canada's Protected Areas Establishment and Conservation Directorate. For the past 32 years, he has worked as an ecosystem scientist on conservation and protection issues across Canada's network of national parks and national marine conservation areas. Welcome, Scott, and I see that you're all good to go, so the floor is yours.
Okay, thank you very much, Sharon, and hello, everyone. And hey, my gratitude to Greg and Anders. You really set the stage. It was a nice introduction to the importance of protected areas and their role in Great Lakes conservation. So I'm presenting from Lions Head, Ontario, and the unceded territory of the Saugeen Ojibwe Nations. Today, I will share some of Parks Canada's experience with Great Lakes coastal wetland conservation. That is how we, as a protected area agency, have come to understand and respond to climate change and biodiversity loss in our coastal wetlands. For context, Parks Canada is the largest federal real property manager in Canada. We are a representative network of national parks, national marine conservation areas, and national historic sites. As such, we also face a representation of the impacts and threats facing wetlands across the nation. So, for example, water flow regulations and climate change threaten the flood regimes of the Peace Athabasca Delta and Wood Buffalo National Park. Invasive green crabs in Ketchikan or hyperabundant snow geese population in Wapusк are just some of the species-based threats our wetlands face. But we're also involved in mitigation. For instance, we have our research agenda to assess carbon stocks and fluxes in our protected ecosystems, including the dynamics in peatlands and permafrost thaw, and also blue carbon stocks in marine coastal wetlands. So in terms of Anders' comment about protecting climate refugia, we're really coming from a place where all wetlands and groundwater sources need protection. We are a place-based organization with a mandate to protect ecological and commemorative integrity and foster public understanding and appreciation. Our sites are also within traditional territories where there's a clear and evolving commitment to respect and maintain Indigenous relations. And it's sort of the reason for sharing this slide is to provide context in our thinking and approach. That is our protected area straddle policy and action on the ground, and that we administer these sites as complex social ecological systems. In Ontario, Parks Canada administers 49 sites, 19 of which are directly on the Great Lakes. And this includes all the national parks and the 2 national marine conservation areas. Within these sites, these Great Lakes sites, there are over 130 Great Lakes coastal wetlands or wetland complexes protected. For today's talk, I'd like to introduce a select cross-section of sites and the issues they face. This extends from the relatively undisturbed Lake Superior National Marine Conservation Area to Point Pelee National Park in Lake Erie and the Rouge National Urban Park on Lake Ontario, 2 sites nested in highly developed landscapes, as well as 2 sites in between at Fathom 5 National Marine Park and Georgian Bay National Park on Lake Huron. In terms of biodiversity loss and the climate crisis, protected areas are increasingly being framed as natural solutions. Certainly one of the chief reasons for advancing the 30% of lands and waters conserved by 2030 commitment that Anders mentioned is because of that role they play as natural solutions. However, when we're considering this, it's worth recognizing that there are 2 sides to natural solutions. There's ecosystem-based adaptations, which is the use of biodiversity and ecosystem services as part of a strategy to help people adapt to environmental change. You've all thought of like using wetlands to prevent flooding. And there's also ecosystem-centric adaptation. It's about helping nature adapt to changing environmental conditions. That speaks to climate refugia, connectivity, restoration, control of invasive species, those sorts of things. So consider both. I'd like to start this talk at Point Pelee National Park. While this is a relatively small site, it's 15.5 square kilometers, the marsh at Pelee is one of the largest remaining in southern Ontario and is recognized as a Ramsar wetland of international significance. Many of you know the complex conservation issues facing the site, from the early dike and draining that effectively fragmented the marsh regionally, to a legacy of contamination and altered hydrology and nutrient loading. On this slide, I'd like to sort of focus on the expansion of invasive species, which has led to a 10% loss of open water within the marsh since 1959, you can see on the image. In partnership with Caldwell and Walpole Island First Nations, DFO and others, the park is undertaking a marsh restoration project that includes increasing interspersion. Starting in 2020, the goal is to remove 4 hectares of cattail and 4 hectares of floating and 1 hectare of rooted Phragmites, thus creating channels and increasing open water and edge habitat. As well, the intent is to improve visitor experience by expanding canoe routes, improving viewscapes, and providing educational opportunities. Again, we're looking at both species conservation, maintaining ecological integrity, and offering opportunities for visitor experience. So I really like these images. They're just very impacting. So even within the year, within 2021, the evidence of an improved marsh is quite clear. So you can see the before and after photos. And a few of the observations in the lower image there of that in these newly opened areas include least bittern nesting, thriving patch of swamp rose mallow, and basking snapping turtles. While these restoration projects are good news and really moves the park towards a more desired state, and I should say a more resilient and desired state. Because resilience itself is just a system property, and you can have a resilient state that's in an undesired state. As a Phragmites monoculture can be quite resilient. So we're really trying to push these things towards resilient desired states. But looking at these images, these model results from Pete Suzek based on lake level projections, these images really shadow our discussion and present what is essentially a nightmare scenario for Pelee. Given the high degree of uncertainty and limitations on what can be manipulated or controlled, such analysis really reinforces the need for more scenario-based planning to explore alternative futures and the risks posed by the decisions and the adaptation actions that we're taking today. I wish I had an answer. We're not here yet. These images again are very impactful, very concerning, taken very seriously. But how we move forward still is a big unknown. But the recent Pelee Hackathon brought together a lot of leading edge thinkers on this issue. Environment Canada's Coastal Resilience discussions, many of you may have been just on a meeting with hosted by Jeanette Anderson, and other initiatives are all steps in the right direction. And in these meetings, and even in some of the earlier discussions, Pete presented on this work earlier in the week. And he had some very bold and compelling ideas that we should be considering and moving on. One positive thing I would say is that the site is also recognizing that it cannot be managed in isolation. It cannot be managed as a fort. It has to be connected to the conservation at scale. And further, the site can't simply focus on historic conditions. It's like restoring to some historical analog or historical state. That's just untenable these days. It's like driving while looking in the rear view mirror. It doesn't prepare you for what's about to hit you. So as the mantra goes, we must manage for change, not just persistence. And persistence of species in situ was our comfort space. To be honest, in particular, that was restoring to historical states was occupied a lot of our restoration and conservation efforts. But now we're really forced to, in this period of rapid environmental change, manage for change. So how do we do this? How do we make what are unavoidable decisions strategically? To this end, really seeing, and it was my colleagues in the U.S. National Park Service that brought it to my attention, is a RAD framework, and we're leaning on it more and more. It has three distinct choices: resist, accept, direct, in response to strong human-driven ecological changes. All these choices constitute adaptation if they're done strategically. The approach helps to focus managers' action and intention. Exactly what are we trying to do? Sometimes we do what we've historically done, but rather than strategically thinking about what we ought to do or agree as a community would be the desired state to move towards. RAD encompasses all possible options. It's neutral. It doesn't elevate one choice above another. It recognizes the context. That context is everything. So I'm thinking about Pelee. Resist option is prohibit fishing, which they've just done. They used to be catch and release, and now they've prohibited all fishing. The restoration actions that they've taken and their attempts at controlling invasive species are all we consider strong actions in the resist domain. Accept would be managing for novel ecosystem assemblages, species assemblages, and direct. We get into some what historically has been contentious issues like species translocation or habitat improvements for species that are maybe better adapted to a novel or hybrid Pelee marsh in the future. I don't have much to say on this. It's a little figure I created to help me conceptualize, model how these the resist, accept, and direct options can be fit together and can feed each other. But I just wanted to make sure it was captured here in the slides, and if you're referring to them afterwards, you can see how I think about how I map these sort of decisions out. So here's an example how it could work. To better understand and prepare for projected changes in bird distribution, we recently completed a study with Audubon, Birds Canada, and the Canadian Wildlife Service. Using climate suitability models, we determined that on average across all national parks in Ontario, we are expected to experience a 25% turnover in bird species due to colonization and extirpation under a 2 degrees Celsius warming scenario. So maybe by 2050, you can expect a quarter of the birds in your bird communities to be different in your national park. That's stunning. So this image here illustrates the concern. Here it shows the projected range shifts for the American bittern. And you can see it's the potential extirpation at Point Pelee and the Rouge National Urban Park. It's worsening at most sites like the Bruce Island 5, Thousand Islands, Georgian Bay Islands. The only exception are the sites up in Lake Superior, Puckasaw, and Lake Superior National Conservation, where it's improving conditions, climate suitability for the American bittern. So bringing all this together, so that bittern was just one species, but we looked at the change in the entire bird communities for every national park. And so to help managers identify priorities, this figure identifies each park's anticipated trend group based on projected changes in species distribution. So parks that are expected to have low change are most suitable to be managed for persistence. Recall earlier I spoke about we're managing for change, not just persistence, but so these sites manage for persistence. So emphasizing actions that protect species in situ, help to build or maintain system resilience, managing disturbances, climate smart restoration, reducing exposure to non-climatic stress, such as invasive species, fragmentation, road mortality, pollutants, we all know the stresses. However, the parks that are in high turnover or high potential colonization and high potential extirpation trend group need to consider managing for change, and it might be the more effective option. So facilitating adaptations such as improving habitat connectivity and more intensive management actions, protecting nest sites, those sorts of things. Scenario-based planning, which is different than adaptive management, really looking at the risks of your decisions. Recalibration of management goals for novel ecosystems, not just restoring towards native species in their distribution and abundance. It's not possible. So let's move over to Fathom 5. As part of the ecological monitoring program, the site monitors 8 coastal wetlands annually for the past 16 years. And anyone who's worked in coastal wetlands knows you can get a lot of data. And so and at any given site, we could have 80 interacting variables to consider, and from fish and plant abundance to water quality parameters. So naturally, folks like managers and locals and others just don't want to hear how a single parameter is doing. They want to know how is it good or bad? Is there a trend to be concerned about? So like many of you, we present using various indices. One of the earliest indices we adopted was the Coastal Water Quality Index and Fish Wetland Fish Index developed by Dr. Pat Chow-Fraser in her lab. These water quality and WFI work well for us and provide an index value relative to a stress gradient of coastal wetlands across the Great Lakes. So really good, work well on that. Looking if you've got a nutrient-loaded, high turbid, high algal dominated state, or a macrophyte dominated, clear turbid, clear water conditions. If you're new to these indices, a positive WQI is considered good. In fact, Fathom 5 is excellent water quality, and the WFI, the fish index, is also good, and with an increasing trend due to in the water quality is also evident. But we are most interested in also looking at resilience. A measure of resilience often looks at the properties that promote resilience, such as a redundancy, response diversity, or adaptive capacity. But we were interested in a measure of resilience based on the system's response, not just the elements that promote resilience, but how your system is responding. And from other studies, such as regime shifts in shallow water lakes, it appears as resilience decreases, system feedbacks begin to weaken, and we see changes in dynamics, including an increase in variability and recovery time. But importantly, we want to distinguish baseline variability from something that may be indicating a loss of resilience and pending regime shift. To this end, we used a multivariate distance-based control chart analysis to indicate when a wetland may be going out of control. If you can look at this image here, you can see those when a deviation exceeds the expected 95% confidence limit, the red line in the plot shown here, we investigate a potential decrease in resilience. So in Big Tub Harbor, we saw the shift to a Gobi-dominated state. At Russell Island, the prolonged lake level effect and stranding, we saw a transition to a lithophilic, bass-dominated community with low colonization potential. Hay Bay, we saw the recovery of northern pike and yellow perch and higher lake levels. I'd be remiss if I didn't take the time to acknowledge Greg Main and all the other UCC colleagues and thank them for all the inventory, modeling, and vulnerability assessment work they've undertaken as part of the Coastal Wetland Project. Three of the study areas are in Parks Canada sites, 4 if we include the earlier work at Herkett Cove and Lake Superior. I've only had a quick peek at the GIS data layers, but already I can see how this will help to inform our management actions. For instance, the Hay Bay site shown here, which is in Fathom 5, is projected to experience a landward migration of wetland area. And this complements our shoreline and in-water work permitting. So we can reinforce the need to continue to restrict shoreline alterations in the head of the bays to minimize or mitigate the potential for coastal squeeze. The Rouge is a 79 square kilometer urban park in the Greater Toronto area. As expected, its urban setting and land use history, it faces considerable conservation challenges, but it also offers people an important connection to nature and provides a critical refuge for species in an otherwise highly disturbed areas. In terms of coastal wetland, Rouge Marsh is affected by both the valley and Lake Ontario. And with the TRCA, they have prioritized projects using a framework that weighs ecological benefits as well as others, such as visitor experience opportunity, agricultural benefits, and the protection of Indigenous values. One of their higher profile projects involves supplementing the park's declining Blandings turtle population by head starting and releasing juvenile turtles. Essentially, turtle eggs are collected from at-risk nest sites in stable source populations. They're incubated and hatched and raised at the Toronto Zoo for 2 years before being released into the Rouge. In the big picture, these species use a wide variety of wetland habitats and effectively serve as an umbrella species to drive watershed conservation. And since 2014, 300 juvenile turtles have been released and 80 hectares of wetland have been restored and 13 in-stream barriers removed. Georgian Bay Island is the smallest national park and core protected area in the Georgian Bay Biosphere Reserve. Over 20% of Beausoleil Island shoreline is colonized by invasive Phragmites. As the story elsewhere, this perennial grass has been replacing or displacing native species. The Impede the Breed project is attempting to reduce Phragmites and restore the natural shoreline around Beausoleil. And a key strength of this project is its conservation partnership with Georgian Bay Forever and Severn Sound Environmental Association. For instance, manual deep water stem cutting, the use of the Truxor amphibious vehicle, the project's removed Phragmites in over 90 sites in 2021. A measurable improvement in density and distribution has been noted, as well as anecdotal observations of musk and map turtles returning to the site. In terms of Phragmites, Lake Superior National Marine Conservation Area has the benefit of learning from the impacts and experiences of the lower lakes. This site has an active surveillance program and has been able to take action to control and eradicate patches while they're still small. Final thoughts. Protected areas are the cornerstone of biodiversity conservation and places for learning and connecting to nature. We need to manage for ecosystem transformation. Integrated coastal zone management is extremely important. There's a 30 by 30 targets we shall be tracking and supporting, and Indigenous protected and conserved areas are also important to consider. Thank you. I may have presented, but this really reflects the hard work of my friends and colleagues in Parks Canada, and a special thank you to Greg May.
Wonderful. Thank you for the excellent presentation, Scott. I'm glad that your presentation shared examples from the Upper Great Lakes, which we recognize has been underrepresented in our presentations this week. And I'm sure there is a lot of questions from the audience, so please input your questions in the Q&A box. Scott, in the middle of your presentation, you had a map of trend groups showing proportion of extirpations. And the highest potential extirpation, the ones with white dots, appears to be concentrated in Lake Huron, Georgian Bay, and Lake Ontario. Can you elaborate on what is driving these higher proportions of potential extirpation, and is there anything we can do about it?
The area has historically a transition between northern and southern affinities, and what we're seeing is really more of the northward shift. As species move northward or up and yeah, so that you're seeing the northward shift of species and new species coming in. Our models also considered, it wasn't just climate suitability. We looked at landscapes, water availability, vegetation cover, urban development. So you also, this area is highly developed, so there's a lot of some of the suitable habitat, and especially in southern Ontario, for these species coming in. But hope that helped.
That is very
there's
helpful.
a paper. It's in +1. If anybody is interested, I could share the link to it. But just look national parks, Google my name, +1. It's available.
That's great. That's very helpful, Scott. And if you could share a link to that paper during our break, that would be very helpful as well.
Okay.
Our next question for you, Scott, is that we're glad to see interest in adopting a more scenario-based planning. Just wondering if you can elaborate on how you and others at Parks Canada plan to apply scenario planning in your work?
No, it's a good question. I mean, so first of all, just maybe for context, adaptive management works where there's a lot of uncertainty, but there's also controllability. You can manipulate it. So it's an experiment adaptively. You put a hypothesis, you do something, and you learn from it and you improve. Scenario-based planning really comes out of the military and these folks that are dealing with massive potential for massive disasters and that sort of thing. So it's where you're putting out alternative plausible futures, and you begin to look at the risks of your decisions and what you should be doing for planning for those different things. We have been slow to pick up on the scenario-based planning. I've been involved in climate workshops where we present alternative futures, and we look at how we could get towards those. What are the impacts, and what are the things we could be doing in our sites? So we've had adaptation workshops. Specifically I've been involved in 13 different sites across the country. But I would look to the U.S. National Park Service. They have a really good model on it's explicitly using scenario-based planning. So the U.S. National Park Service is where we're starting to pick up. We're learning more from them, and we're starting to use their approaches more and more. But we do have adaptation workshops that consider futures, but not to the rigor, I would say, that a true scenario-based approach would.
That's wonderful, and looking forward to that future work. Our next question is about Indigenous protected and conserved areas on your last slide there, Scott. You've alluded to some work with Indigenous communities already in your presentation, but I wonder how Parks Canada is working to support Indigenous-led conservation, and whether you can share a few examples of this, if there are any, within the Great Lakes region.
Well, you couldn't pick a site that doesn't have a sincere and respectful relationship with the Indigenous communities, whether it's Point Pelee, Caldwell, Fathom 5, and Saugeen Ojibwe nations, or all the sites, and it would are developing their own relations. So for instance, in Fathom 5. Working with the Saugeen, there's a project right now called Together with Guganai, looking at whitefish decline, and Parks Canada and the Ministry of Northern Development, Mines and Natural Resources and Forestry and Saugeen Ojibwe nations are working collaboratively trying to understand whitefish decline. It's a multi-million-dollar project. But at the park level, there is the park management and the Saugeen Ojibwe Nations meet regularly. They're working through management plannings. They work through all the sort of the big land use decisions of the development decisions that happen in the park. So there's a relationship, an explicit relationship there for making those sorts of decisions. So I also worked in Guayhanas for a period of time, and that was an example of co-management where the Haida Nation and Parks Canada working to protect not only Guayhanas National Park Reserve, but also the Haida Heritage Site. So every site, if you want to know wherever you are, if you're interested in learning what the relationships like, I'm happy to connect you with those sites, and you can learn from that.
That's great. Thank you for that, Scott. And our final question before we go into the break is, Scott, you mentioned Rouge National Urban Park in your presentation. Are there any plans for more urban national parks on the horizon? And if not, are there any sites where you think should or could become an urban national park next?
Yeah, no, it's another. All these have been good questions. I should have said that right. I mean, thank you for raising these questions, and I appreciate it. Yeah, sometimes I feel like I work in establishment because people are always interested in what's new, and we're going to have an NNCA on their legs and all. Great question about National Urban Park. I can say that we are working towards one in Windsor. And that there are prospects for others. I'm not sure where. I've got some ideas, but I'd be guessing, and I might not want to be quoted on that. But there are other major urban centers in the country that are looking at national urban parks, and the Rouge has been a good model for that.
Wonderful. Thank you for sharing that, Scott. And thanks again, Scott, for the excellent presentation. We will be inviting Scott to rejoin us for the panel discussion at the end. So please do keep your questions coming through the Q&A. Let's take a 5-minute health break to refresh before our last set of presentations before the panel discussion. And we are back. Next, we'll hear from Robin and Dan. Robin, please go ahead and share your screen while I provide a brief introduction. Robin Rumney serves as the Ontario Key Biodiversity Area Regional Coordinator at Wildlife Conservation Society Canada. Her current work involves researching Ontario's biodiversity and collaboratively proposing key biodiversity areas that are critical to the maintenance of wildlife and biodiversity. And Dan Kraus is the Director of National Conservation for the Wildlife Conservation Society Canada. He supports and manages Wildlife Conservation Society Canada's portfolio of national initiatives, including key biodiversity areas, One Health, biodiversity policy, and natural climate solutions. And prior to WCS Canada, Dan worked for the Nature Conservancy of Canada for over 18 years. Robin, I see that your slides are up and in full presentation mode, so I'll pass the floor to you.
Great, thanks so much, Sharon. Yeah, thanks for the great introduction. So today, Dan and I are going to be talking about identifying key biodiversity areas to support Great Lakes coastal wetland conservation. So I'm going to start off by giving an overview of the Key Biodiversity Area, or KBA program here in Canada and Ontario, and then give some examples of some of the KBA sites that we're working on in the Great Lakes. And then Dan is going to finish off by talking about how the Key Biodiversity Area program fits into the larger conservation landscape within the Great Lakes coastal wetlands. So key biodiversity areas are sites that contribute significantly to the persistence of biodiversity. So these are sites that are critical to the maintenance of biodiversity because they hold high concentrations of rare species and species at risk. This means that if we can find these sites that have high concentrations of these rare and at-risk species and ecosystems, that we can potentially find the areas that we need to protect and designate in order to prevent biodiversity loss. So the Key Biodiversity Area program aims to produce a layer of biodiversity knowledge that can be used to enhance decision-making and planning. So we're hoping that these KBA data sets can be used to aid in things such as protected area design, land use planning, environmental assessments, and community science initiatives. So KBAs don't have a management prescription. So this means that when a site is designated as a KBA, it doesn't mean that there is any land use limitations or that it will necessarily become a protected area. And this also means that we're able to do our KBA designations at any site regardless of land use. So we've designated KBAs in urban areas, in areas impacted by mines and forests, forestry operations, and also in existing protected areas. So why are we working to identify these KBAs in Canada? So this work is in response to a decline in Canadian biodiversity. So there's been species that have become extinct that were once in Canada, and also many species that were extirpated that used to be in Canada or regionally within certain areas and are no longer there. So we're hoping that KBAs can drive protected area placement to really prioritize biodiversity and protecting these rare and at-risk species and ecosystems moving forward. So the Canadian government has a commitment to Canada Target 1 and now the 30 by 30 initiative, which means that Canada is looking to protect 30% of its landmass by 2030. So the role of KBAs really comes in here by helping us recognize which sites we should be prioritizing for this increase in our protected areas. KBAs are seen as a scientifically robust and credible tool that can help capture where these high biodiversity value sites are and inform our future conservation decision-making. Our approach to KBAs in Canada is first and foremost very collaborative. So the KBA program is being run by a variety of environmental NGOs, government agencies, First Nations, and different academic groups across Canada, and also in partnership with the global program as well. So we're involving First Nations communities and using Indigenous traditional ecological knowledge throughout this process. And we also have an extensive review process, just adding to the collaborative nature. The KBA program is also comprehensive. So this means that we're trying to identify as full of a set of KBAs across Canada as possible. And this really ties into being useful for land use planning and for protected area planning. So we need to know where all of these sites are that have these high concentrations of rare species and species at risk in order to best guide land use planning. We also have both species and ecosystem criteria. So this means we're working at both the species and ecosystem scale. And actually all species and all ecosystems can be included within the KBA program without bias, as long as they reach our strict KBA thresholds. All of this is as permitted by data availability. So rather than conduct our own fieldwork for this program across the country, we're using data provided by the conservation data set centers and also our other partners. So this means we can work quite efficiently, but also means we might have limited data in some areas. Luckily in Ontario, this hasn't been a problem, especially around the Great Lakes. Finally, our KBA program is designed to be relevant. So we're really trying not to reinvent the wheel. We're trying to integrate this within the existing Canadian conservation frameworks and learn from past designation and projects and really utilize that existing data and knowledge and partnerships that are already out there. So we're hoping that the KBA program can be one piece of the puzzle to guide conservation and can work in partnership with other tools. So our KBA work here in Canada is based off of 2 KBA standards or KBA guidebooks. So we work both with the global and the national KBA standards, which allow us to identify KBAs at both a global and a national scale, meaning sites that are important globally, and then also those that are important nationally, where the species might be common in other places in the world, but rare here in Canada. So we have 5 criteria outlined in the standards that we're looking for in Ontario and the Great Lakes. And these include, first and foremost, the threatened biodiversity criteria. So this is the one that I've been working on most, and I'll be sharing examples on later. But these are for species and ecosystems that have been deemed to be at risk. And depending on how at risk they are, we need a certain percentage of the species or ecosystem to be found at the site compared to the global or national population. So we're basically calculating what proportion of the species or ecosystem is at the site. And if it meets this threshold, then it is a KBA. We're also looking for geographically restricted biodiversity. So these are sites that where the range might be restricted. Also sites with high ecological integrity, although I won't be talking about this one as much. Sites that are important for biological processes such as migration and breeding, and sites that are irreplaceable, and another criteria that I won't be getting into today. So in the Great Lakes region, there are two kind of methods that we're using to get at KBAs. The first method is looking at the existing important bird areas, or the IBAs. And this work is led by Birds Canada. And what they've done is they've reassessed all of the IBAs across Canada under the new KBA criteria. And many of them have been designated as either global or national KBAs based on this. So the map on the left, you can see the green areas in Ontario have been reassessed by Birds Canada as KBAs. And this is still subject to change, but these are some early results. On the American side of the border, there's also many IBAs that have been identified by the Audubon Society and BirdLife International. And they haven't started assessing these as KBAs yet, but they have a large network to work from if they do. So the other part of our work is looking at these IBAs that have been reassessed as KBAs, and also finding new sites to find non-bird triggers. So this is all other species and taxa and ecosystems. So and the yellow dots show the sites we're looking at to date. And these are just some of them. And based on our limited capacity, these are the ones we're focusing on right now, but in future we hope to add to this map. And some of the Great Lake wetland sites include Manitoulin Island North Shore, Eastern Lake St. Clair, Rondeau, and the southern shore of Prince Edward County. I'm just going to go through a few quick examples of some of the Great Lake wetlands KBAs that we have in progress to give you an idea of how this works. So the first example is Long Point. So this is one of the most well-known IBAs in Ontario, some important bird areas. And Birds Canada has reassessed it and found it to meet the KBA criteria. And it also has a few other conservation designations as well. So the bar graph on the bottom right shows the different COSEWIC or species at risk nationally that are found in the area. And so there's quite a few across different taxa. So we're assessing these to see which might be KBA criteria. And so far, fish such as warmouth might meet that, Fowler's toad, and many other species as well. Another site in Lake Ontario that we're working on is the Dundas Valley and Dundas Marsh site. So this includes Cootes Paradise, which is the largest wetland in the western end of Lake Ontario. And this is another important bird area, or IBA, that Birds Canada has reassessed and found to be globally and nationally significant as a KBA for birds. So we're looking to add species to this nomination, such as potentially the species at risk mussel lilliput, and as well many different species at risk plants and other taxa as well. And this site includes both Cootes Paradise, just the wetland, and also some surrounding upland area. So hopefully this designation could provide benefits for connectivity and climate change refugia, as well as just benefits to these wetland species. And the final example that we're working on is the eastern shore of Georgian Bay. So this site is in really early stages, but right now it's a UNESCO biosphere region. So you can see it outlined in red. And we've identified it in our scoping as being potentially important for reptiles such as Massasauga and Blanding's turtle, and also some plants. This one's not in a wetland, but forked three-awned grass is in the area, and it's nationally rare. It also has some rare ecosystems, such as the Atlantic Coastal Plains disjunct ecosystem. So we need to work closely with the different conservation groups and knowledge holders and First Nations in this area to figure out if we want one large KBA over the entire coastline, or if we're going to be looking for concentrated sites within this already concentrated zone for these species to come up with smaller KBAs. So hopefully we'll start working on this site shortly, and we'll have more information on it moving forward. Thank you very much. I'm going to pass it over to Dan now.
Great. Thank you very much, Robin. That was a great introduction to key biodiversity areas. And Robin, I know you're going to switch my slides for me just so we can avoid a sharing screen, so I'll just try to signal when I need that done. I really do think key biodiversity areas are one of the most important conservation initiatives that are happening in Canada and around the world right now. I've been thinking about priority places for conservation for a long time. Around the Great Lakes, Red mentioned these biodiversity strategies, which were really sort of one of the first attempts to think about, where are the most important places for protecting and restoring nature within this basin. I think one of the most important things about the biodiversity strategies was, up until then, a lot of our planning around the Great Lakes was about all the stuff that we've messed up already around the areas of concern and cleaning up these toxic sites. And there's certainly great progress we made. There's lots of work to be done. But there are places in the Great Lakes that are incredibly significant from a national and a global perspective. Robin mentioned one of the key biodiversity area criteria are things like geographically restricted species that have these very, very small ranges and may be endemic to a country or to a particular ecoregion. And we have lots of species like that, like lakeside daisy or Lake Erie water snake, that do occur in these very small geographies around the Great Lakes. We also have these incredible migrations. Many of these have been recognized in important bird areas for decades, but there may even be seasonal aggregations of some fish species that could trigger KBAs as well. And the one I'm really excited about are these threatened or geographically restricted ecological communities. If you look across North America at the diversity of ecosystems, there's actually few places that have the diversity of ecosystems that we find here in the Great Lakes. You get it in the Rocky Mountains, and that's driven by elevation. Here in the Great Lakes Basin, that diversity of ecosystems, ranging from alvars to Great Lakes beaches and dunes, is because they sort of only occur around this large freshwater ecosystem. In those Great Lakes biodiversity strategies, I think we did a pretty good job trying to identify where some of these priority places for nature are. We called them different things depending on the different reports. Some of them were more expert driven, some of them were more driven by existing information. Some of them we brought groups of people together and used a lot of data to try to figure out where were the most important places for different coastal systems or for wetlands around the Great Lakes Basin. And so I think key biodiversity areas have an opportunity to build on some of this work that's already in the biodiversity strategies. It's already within the LAMPs and other work that's being done. I think the advantage of it is it brings it to light. It's not sitting in a report. This information will go into a national and a global registry where people will be able to pull out the maps and find out what made these areas important. And we know that these designations, as Robin said, there is no management prescription for them, but we know that they can have an impact. If you look at other types of designations, from Ramsar sites to important bird areas to Alliance for Zero Extinction sites, just having that designation, just having that pedigree on that site does help in conservation. Sometimes that's driving new protected areas, sometimes that's policy, sometimes that's just encouraging people to manage and look after these sites. So, very optimistic that key biodiversity areas, just like important bird areas did, will help to kind of assign and emphasize the value of these places as we think about planning and stewardship of these areas. So I want to talk to you a little bit now about just how maybe KBAs can help to advance conservation around Great Lakes wetlands and help in terms of their resilience. The first one is around identifying those key areas and conserving them. As we think about trying to protect more areas, we hear a lot about protecting 30 by 30. We want to make sure that we are protecting the right places. It's not just sort of any old 30% of Canada or of the Great Lakes, but really those sites that are the most critical for biodiversity. And key biodiversity areas can certainly help with that. The information that is available, the more information that we hope to have available, really kind of provide this preloaded set of conservation priorities that can guide new Indigenous protected and conserved areas, or can help with land trusts. You don't need to justify why these places are important once they're in the national and the global registry for key biodiversity areas. I think these places can also help with existing protected areas. You know, Scott kind of talked about sort of like the fort or the fort mentality of protected areas, but key biodiversity areas won't necessarily stop at park boundaries. And when we think about species or ecosystems that are necessary for maintaining ecological integrity, they may occur outside of parks. And those key biodiversity areas that straddle those boundaries might support thinking and hopefully actions in that greater park ecosystem. And KBAs as well can help in terms of thinking about sustainable use of lands and waters. It's not just about protected areas. They can help thinking about where development should and should not occur by incorporating them into impact assessments. They can help to signal to developers, where there are clear no-go zones, where development proposals are not just impacting perhaps natural heritage of local or regional value, but really impacting biodiversity that's significant from a national or a global perspective. There may be some value in KBAs as we think about biodiversity offsets. Certainly Ontario has its new program around offsets for species at risk. And where those offsets are directed, maybe key biodiversity areas, enhancing key biodiversity areas, helping to secure them may be something that can be done. And then the other one is around corridors that key biodiversity areas can kind of act as nodes within a network of protected areas, conservation designations, indigenous protected and conserved areas, and will help us kind of think about how we need to connect these places. When we think about KBAs as well, we can think about laws, policies, and programs. They can help to guide land use planning, land use zoning. Again, that pedigree of a KBA with its rigorous standard and review, knowing that has local input, it's been reviewed by experts to be put into the national or the global database. It can help local governments or our citizens to better plan and maybe defend natural heritage systems or green spaces within official plans. And there may also be a role for things like incentive programs for private landowners, be that through stewardship support or tax incentive programs, and recognizing that many of the wetlands and other important habitats are likely to be KBAs around the Great Lakes coast will remain in private ownership, and that designation of those as a KBA may be a way to direct those incentive programs. The next one is just about kind of building that awareness about the amazing biodiversity that we have around the Great Lakes. And I think Greg had a slide that talked about kind of a broader participation and encouraging learning. And this may actually be like one of the main strengths of key biodiversity areas. There will be key biodiversity areas in urban areas, just like we have important bird areas like Leslie Spit. Those can act as gateways for people to learn about nature, and nature that's not just important for the Great Lakes, but these are places that are as significant as Amazon rainforests or coral reefs when it comes to protecting global biodiversity, and sometimes they are in our own backyard. Maybe eventually some of these sites, it can be focal points for community-based conservation planning. They're not all going to become parks and protected areas, and even using things like the open standards of practice for conservation to develop plans within KBAs to come up with effective management strategies, I think is worthwhile to consider. Maybe opportunities to kind of have KBA practitioners, KBA stewards get together to share their experiences and how conservation can be done outside of parks and protected areas. And the other one is just about community identity. I've seen this happen, that when local people know a place is important, but when you kind of put that stamp on it, that this place is important from that national or the global perspective, and it's been validated and agreed upon by experts, it can help to just kind of ignite and inspire that local passion for conservation, which is so important in terms of defending those places and stewarding those places and wanting to see them protected. And then the last one I have is around monitoring. And just monitoring the health of Great Lakes wetlands and other ecosystems. There is going to be this key biodiversity area dashboard that's going to provide all of this information. So we'll kind of know what's where, but perhaps key biodiversity area protection, wetlands or other ecosystems could even be an indicator in future State of Great Lakes reports. Things like looking at the percentage of wetlands that are covered by key biodiversity areas, or the percentage of key biodiversity areas are within protected areas, or have some other kind of effective management could be useful for that. And just final slide then. Just thank you. I would encourage you to visit the KBA Canada website. It'll have just some of the information that's on there. You can sign up for some of the upcoming webinars to learn a little bit more. And just in conclusion, I mean, I think what's really exciting about this is that these are being done around the world, and Canada is kind of leading in terms of developing these key biodiversity areas. We're getting through the implementation. We're kind of limited a little bit right now in sort of where the sites we can work on, but we're hoping to kind of ramp up resourcing for those, but hoping that within the next few years, we'll have this complete set of key biodiversity areas around the Great Lakes. Thank you.
Wonderful. Thank you for the great presentation, Robin and Dan. We will take a few questions before our final guest presentation by Kristen this afternoon. So Robin and Dan, you presented the many different tools available in the conservation toolbox, including policies, incentives, and land trusts. Are there any tools that you would like to see used more for the conservation and protection of coastal wetlands in Canada?
I can start off with that, Robin. I mean, certainly long-term protection through Indigenous protected and conserved areas, or more national parks, or more conservation authorities has a lot of attraction, because that's sort of what we think about traditionally as protected and conserved areas. So, I hope we can do that, but we do need to think about other options. I am encouraged by some of the private land stewardship incentives that are out there. In Ontario, we do have things like managed forest tax incentive program and conservation land tax incentive programs. I think that those are great. I think we do need to do more around those. There's some really innovative projects in Africa where people get basically like their taxes, they can actually have like a negative assessment rate for protecting certain types of habitats. I think that that's something that municipalities, if implemented, would probably need to be supported by the province. But there all are these kind of creative private land solutions that are out there. But I think the other one too is, we just kind of need to break down this dichotomy we have between nature versus economic development, and some of the stuff that Greg was showing around, just the economic value of these places. Like, even if you don't love nature and you're driven by dollars and cents, I think that more of that can be helpful in kind of thinking about funding and support for those types of things.
Wonderful. Thank you for that, Dan. And Robin, did you have anything else you would like to add about any tools you would like to see used more?
From my perspective of doing more of the data scoping, I think it could be useful to have more, I guess, consistent across the board surveys in some of these sites, just because we're looking for that data to confirm where these KBAs are. And many of the big national and provincial parks, there's really, really good data sets for some of these wetlands. But in some of the lesser access sites or places like that, it would be good to have some sort of regular survey. And I know that would be costly, but it would be good to get some more baseline data for some of these sites.
That's great. Thanks, Robin. And I'll pose a similar question I posed to Scott, is how is Wildlife Conservation Society Canada working to support Indigenous-led conservation, and whether you can share any examples with us within the Great Lakes Basin. Dan, if you'd like to go first.
The specifics are probably better for Robin, but I think one really unique thing about the Key Biodiversity Area Program in Canada is that it's not top-down driven. There's lots of national organizations like Birds Canada and Environment Canada Climate Change that are participating, but for a key biodiversity area to make it to the nomination process, there has to be that local validation and buy-in. And I think almost all of the key biodiversity areas, and this is part of the reason why it's taking so long, is getting all that local input, but it certainly includes the input and the review by Indigenous peoples where these key biodiversity areas are. And I think that is essential.
Yeah, definitely. Just to add off of that, I would say part of trying to make KBAs very collaborative is working with different partners, either the First Nations themselves or groups that already have strong First Nations partnerships. So for example, the NCC in some areas might own some land that could be a KBA. So then we can work with them to make sure that all the appropriate stakeholders and First Nations are involved from the get-go. And we've ran some workshops to notify all of the First Nations and get their involvement, but it's something that we're continuing to try to improve on and continue to seek First Nations input as we go. So yeah, it's basically, it's not just a one step in the process. It's as we move forward, we're trying to include them throughout and get their input. And in some cases, we have one First Nation that might be leading the KBA proposal more independently, and we could provide resources to help support that technically. But we're really letting them lead how the collaboration works.
That's great. Thanks for that, Dan and Robin. Our next question is about impact assessments. I'm curious as to whether any of you have come across any good examples of impact assessment of protected areas, particularly related to climate change. Right, Dan and Robin, anything you've come across through your research?
I don't have any really good examples to share. I guess I would say for each site, we kind of conduct as comprehensive of research as we can, and this could include impact assessments and municipal reports and government reports. But we're really relying on the existing data for that sort of thing, and we can feed that into our KBA descriptions. But right now, the KBA data itself is a little bit like we're not doing any climate change projections or impact assessment work ourselves. But yeah, we're basically feeding the existing data into what we have. But yeah, sorry, I don't have anything else.
Yeah, I mean, I'll just add, yeah, I mean, finding a good impact assessment, that's kind of a challenge. I don't know of any that are, that forward thinking in terms of climate change. I am encouraged with some projects that I'm seeing that, like the Herb Gray Parkway in Windsor, for example, where, clearly, what was done isn't what we used to do. Like arguably things are better for nature because of that project, because of improving connectivity, because some of the restoration work, because of involvement in Walpole Island First Nations in thinking about what that restoration work should be. So I mean, I kind of see that as a bit of a model for environmental impact assessment in terms of avoiding where we can and where we need to offset, really going above and beyond just kind of no net loss, and thinking about how we can a net gain in a way that isn't just about kind of net gain for nature and the species and habitats, but a net gain for how we think about nature and our relationship with the natural world, which the Indigenous involvement in that project, I think, was instrumental in.
That's great. Thanks for sharing that, Dan and Robin. And a couple more questions before we go to Kristen is, I wonder about any thoughts or reactions to the concept of climate refugia, as Greg and Anders presented at the beginning, as areas that will remain relatively buffered from contemporary climate change over time and enable persistence of valued physical, ecological, and sociocultural resources. How does this jive with the concept of KBAs, or are there aspects of climate refugia that could potentially link with the KBA identification standards and criteria?
I have something I can start off with. I guess there's two things. First of all, as Dan mentioned, the KBAs are often a bit larger than just one small site. Like it wouldn't just be a marsh, it would be a marsh and then the surrounding habitat. So that could lead to things such as climate refugia being potentially included in these protected areas, and could allow for things like land migration and things like that. And then the other side of it is that away from the Great Lakes potentially, but in the north, we're looking at some larger ecosystem and ecological integrity sites in Ontario. And this is work that hasn't really started yet, but down the road, I know they'll be looked at. And those sites could be important for climate refugia because they would be north of the current range of a lot of the things we're working with.
Yeah, I'll just add to that. I mean, key biodiversity areas don't capture everything. And climate refugia may be one where they're not a specific criteria, but likely sites that have either high biodiversity or irreplaceable sites. I suspect that some of those could be climate refugia. That's not something that we've looked at, but certainly something I think would be of interest for future research.
That's great. Thanks, Dan and Robin. And just a final few questions is Greg is wondering whether the maps of Great Lakes KBAs are currently publicly available as geospatial data files.
Not yet. So we do have a map where you can see just rough placeholders of where these sites will be. And we are going to be sharing with our partners moving forward on a case-by-case basis, but we're trying not to share anything that hasn't been finalized yet. But if you do reach out, I'd be happy to let you know what can be shared right now, and we can, or at what date, hopefully soon, we can start to share some of these sites.
Great. And last question before we go to Kristen is, Neil is wondering whether you have a link to the workshops that you mentioned, any resources from those workshops that are available?
For the First Nations workshop, which I believe is what's probably being referred to, we don't have any, we kept it camera or unrecorded type of thing to make sure everyone's privacy and their concerns was respected. So we don't have any sort of recording from that, but I think that there's a few, if you go to our KBA website, there's some links to some resources that might be helpful, and we might have some sort of report moving forward available, but this workshop just happened, so we don't have anything yet.
Wonderful. Thank you again, Robin and Dan, for the great presentation. I will now invite Kristen to join us. And again, we will invite Robin and Dan to join us for the panel discussion at the end. So please continue to input your questions in the Q&A box at the bottom of your Zoom control panel. And with that, I will now like to invite Kristen to please go ahead and share your screen while I provide a brief introduction. Kristen Bernard is a Program Director for the Nature Conservancy of Canada, Canada's Southwestern Ontario subregion, where she oversees conservation activities within strategically defined natural areas, focusing on land acquisition and stewardship, community outreach, and partnership development. And Kristen, I see that you are in full presentation mode now, so I'll pass the floor to you.
Great. Well, thank you so much. My name is Kristen Bernard, and I work for the Nature Conservancy of Canada. I am the Program Director for Southwestern Ontario. And I'm here to talk to you today about some of the Great Lakes conservation work that NCC is undertaking. At the Nature Conservancy of Canada, we acknowledge that the work we do across the country is on the traditional territories of many Indigenous people. Since time immemorial, these communities have cared for the land, plants, and animals here. We make this acknowledgement with respect and gratitude for the histories, languages, cultures of Indigenous peoples who are with us today, those who have come before us, and for those who come after us. NCC is dedicated to ensuring the spirit of the land is honored and thankful for the continued presence of the Indigenous peoples in these areas today. For those of you who are not familiar with the Nature Conservancy of Canada, NCC is the nation's leading not-for-profit land conservation organization. And since its inception in 1962, we have worked with many partners from coast to coast to coast to protect 15 million hectares of ecologically significant lands. NCC's conservation planning framework has emphasized landscape scale planning in biologically significant areas facing considerable threats with direct protection and often ranking as a priority action. However, as we've heard throughout the week, conservation challenges cross many barriers and are growing in size and scale as time marches on. Effective solutions come in all different shapes and sizes. It is becoming increasingly more important to cast a wider net and work more collaboratively to address complex conservation challenges in effective ways, recognizing that resources and capacity are often limited. My presentation will focus on some of the work NCC is doing to advance Great Lakes coastal conservation through land protection, habitat restoration, and multi-partner landscape scale conservation programs. As we all know, coastal wetlands rank amongst the most biologically diverse and productive ecosystems in the world. However, they are also some of our most threatened ecosystems. Not surprisingly then, is that many of NCC's natural areas across Ontario encompass Great Lakes shorelines and watersheds. From the far southwest of the Western Lake Erie Islands natural area to the Lake Superior coast in northwestern Ontario. In Ontario, NCC is broken into 6 subregions, and we have 19 natural areas where our work is focused. And as you can see, many of these areas have a coastal focus. I will briefly highlight the latest coastal acquisition projects in Ontario, some of our habitat restoration work, and our landscape scale private-public partnerships. The first project I want to share with you today is the Vidal Bay forests and shorelines in the Manitoulin Island archipelago. NCC has had, or Manitoulin Island archipelago has been a focal area for NCC since about the 1970s, when its first property protection project was undertaken. This natural area provides an excellent opportunity to protect undeveloped large tracts of natural land that can contain shoreline, coastal wetland, alvars, forests, and many rare and endangered species. NCC is working collaboratively in this area with many partners to achieve ambitious conservation goals, and the Vidal Bay project is a great example of that. So Vidal Bay, the map here shows you some of NCC's conservation projects that we've led over the years, including Vidal Bay, which is located along the North Channel on Manitoulin Island. So this property was acquired in 2021, and it's about 7,600 hectares, which is a phenomenal size. When combined with the Queen Elizabeth, Queen Mother, Mindu, Minising Provincial Park to the south and the Cobourn Island Conservation Lands to the west, it created a 24,000 hectare network of protected lands. Together, these protected lands encompass about 86 kilometers of Great Lakes shoreline as well. And this is conservation at a scale in the region of the country, Southern Ontario, where large tracts of undeveloped land are fairly rare, and these opportunities come once in a lifetime. Vidal Bay was NCC's first large landscape project, and large landscapes are defined as projects that protect over 5,000 hectares of land, and they're focused primarily on expanding and connecting existing conserved areas. They're important projects to contributing to global conservation efforts, as well as Canada's 30-30 goal. They address biodiversity loss, the climate change crisis, and help to remove the threat of development, which is outpacing conservation. It's important that we can seize these opportunities when they come up before it's too late. NCC took an exercise to value the ecosystem services provided by Vidal Bay's many diverse habitats, and this number totaled a staggering 100 million per year. I know that previous presenters spoke about ecosystem goods and services and their values, and many organizations and agencies are looking at ecosystem services in financial markets as an innovative way to fund more conservation work. We're starting to see this in the insurance industry, particularly as it relates to forest fires and flooding. But there are lots of homegrown examples as well, such as Carolinian Canada Coalition's Carolinian Impact Bond that looks to connect with organizations doing on the ground conservation work with interested investors. And this type of funding may have significant potential to help us achieve more collective impact for wetlands in the future. The next project I'll share with you is the protection of the Long Point Flight Marsh in Norfolk County. Most of you on this call have heard about some of the many aspects of Long Point that make it so significant. It's one of the few remaining coastal wetlands in the Lake Erie watershed with natural hydrological connections and pulses. As we heard in the previous presentation, there are many global, national, and provincial designations. It's a UNESCO Biosphere Reserve, an area of life science, provincially significant wetland, a Ramsar site, an IBA, under review as a KBA, and designated as a priority place for biodiversity conservation by ECCC. Long Point provides habitat for a high number of wetland-dependent wildlife and about 40 federally listed species at risk. It protects inland lands such as the agricultural areas and settled areas from the rising waters and significant storm events. And it's internationally recognized for migratory waterfowl and shorebird stopover locations, and it is a convergence of the Atlantic and Mississippi flyways. In 2020, NCC was able to take advantage of an opportunity to protect the 122 hectare Flight Marsh, which is contiguous with the Big Creek National Wildlife Area and the Long Point Region Conservation Authority's Lee Brown Marsh. The coastal wetland provides protection to the upland agricultural fields, residential and settlement areas, and was one of the only remaining coastal wetlands in the complex that did not have any conservation protection. The protection of this property builds on a network of over 5,000 hectares of conservation lands owned by provincial, federal, conservation authority, and private landowners. In the latter half of my presentation, I'll provide some examples of the habitat restoration for coastal and inland wetland environments that NCC has undertaken in recent years. The United Nations declared 2021 to 2030 the decade of ecosystem restoration. Wetlands are some of the most vulnerable and degraded ecosystems. In fact, globally, the world has lost 85% of its wetlands. In the Great Lakes, watershed wetland loss sits at around 70%, and that number continues to rise. This is especially concerning as Canada is home to 25% of the world's wetlands. Restoration has always been an important component of NCC's work, particularly in southwestern Ontario, where most of our natural cover has been converted. Many organizations are doing great work to restore wetlands, but we need to do more. I'm going to share a few examples of NCC's work in the Southern Norfolk Sampling Natural Area and the Western Lake Erie Islands Natural Area. Historically, Pelee Island was a series of small islands connected by marshes. And the map on the left is a historical map that shows you the extent of the island prior to drainage. In the late 1800s, a series of deep canals were dug and connected up to pump houses in order to create more farmable land on the island. And if you look at this map, many of the areas highlighted in green, those symbolize a lot of the sort of rocky islands that were too high and dry to pump and use for agricultural purposes. And these are some of the areas where NCC has focused its protection work, as these are the areas where the last remaining bits of habitat on the island existed. The red circled area is NCC's Florian Diamante Nature Reserve and the focal point for the next slide, which is an area where we have been creating what we've termed the Big Wetland, a large coastal wetland restoration project in an area of the island that historically was marsh. This map is a topographical map that shows you the extent of the restoration. NCC hired Ducks Unlimited in 2018 to develop engineered restoration plan for the site with the goal of returning most of the agricultural field to marsh. The plan involved constructing a 1.5 kilometer berm, which is shown on the map as the red and white line, around the edge of the wetland using clay excavated from the agricultural field in what would become the land basin in these darker blue areas. The clay excavated from the site created an extremely solid berm, and we were able to use the natural site materials, which is quite important in restoration, so that you're not bringing in any invasive plants or other undesirable things to the site. The clay excavated from the darker blue areas also enabled us to create deeper pockets of wetland habitat within the basin that eventually, when the wetland is full of water, will be deep enough for turtles to overwinter. This project started in 2020. The excavation started in 2020, initially with the removal of ceramic drainage tiles that were connected to the canal at the north end of the property. And it took several months over 2 field seasons to complete. And these photos show you the before and after images. So at the top, we have a soybean field. Most of the farm fields on Pelee Island are farmed in a rotation of soy and wheat, so not the most biologically productive areas. And the photo on the right is partway through the restoration. We are still in the early days of this project. The wetland's holding about 8 hectares of water currently, which is mostly just rainfall and snow melt, but the plan is to get up to about 25 hectares of water holding capacity. And that's the goal from the original engineered design. So we'll slowly be managing water levels over time using what is called an agri-drain, which was placed at the north end of the wetland. And it will allow us to monitor the water levels, the response of the berm, ensure that there's no erosion, that vegetation is holding the soils as we planned, and we'll be able to sort of manipulate and monitor things as we go. The intent is to start this field season by adding stop logs into the aggregate drain that will slowly bring up that water level. And some of the really wonderful immediate results of this project was once the construction was completed, the site was almost immediately colonized with the endangered plant species Scarlatimania. Close to 1,000 plants were counted in the field season last year. And I'll just actually skim back to this design here. Along the southeastern edge of the wetland, 3 salamander breeding ponds were constructed in consultation with researchers from the University of Trent. The limiting factor for smallmouth salamanders on the island was the lack of effective breeding ponds. And so the design of those ponds was based on the research of the University of Trent, and those ponds were colonized with salamanders immediately upon completion of construction. So very much an if you build it, they will come story. And that extends to undesirable things like Phragmites and bog bulrush, which are 2 species that we know are quite aggressive and detrimental to wetland habitats, also readily moved in. So long-term management will not only focus on the water levels, but also managing of those species. And then we'll move along to the Southern Norfolk Sandplain Natural Area, which is in the Long Point, Norfolk County. And in this area, habitat protection led by NCC has focused on connecting existing habitat from the coastal wetlands of Long Point north along Big Creek to Bacchus Woods, the St. Williams Conservation Reserve Forest, and other large tracts of natural habitat, creating a protected corridor of natural and restored lands, including wetland, meadow, riparian, forest, and grassland. In this area, since the early 2000s, NCC has conserved about 2,400 hectares. A key component of the work, similar to Pelee Island, is the restoration of agricultural lands with a focus on restoring wetland habitat. So this map on the right, the properties in green are properties owned by the Nature Conservancy of Canada, and the properties in purple are protected by other conservation organizations and the municipality. And the arrow here shows you roughly where that project area begins. This slide here shows you those NCC properties outlined in yellow. The areas on the properties highlighted in green are areas that we have restored to upland habitat. The purple blobs are areas that have been restored to wetland habitat, and the orange are sites that are to be restored, many of which will be restored this coming calendar year. So again, as I mentioned, our focus is on connecting up and building larger blocks to create sort of resilient, larger tracts of natural habitat for the many species, both common and at risk, that Norfolk County is home to. And a number of inland wetlands have been created through our restoration work. These are considered inlands, not coastal, but they provide important ecosystem functions like water and nutrient filtration, sediments settling, benefit the downstream coastal wetlands, and provide that important connectivity. Since about 2010, NCC has restored close to 770 hectares of habitat in this area. Finally, I wanted to talk about a private land partnership project delivering collective impact for habitat restoration in the coastal wetlands of Long Point. I know there was a presentation earlier in the week. In this presentation, I just want to focus on, I guess, the capacity to deliver conservation outcomes is really being outpaced by the need. And a lot of traditional approaches to conservation often emphasize direct protection through acquisition, followed by restoration, stewardship, and management. And although there are many organizations that are doing excellent work to increase the amount of protected lands, there's also a lot of challenges to doing that work, to say the least, the extreme rise in land values over the last few years. We're not able to acquire all the most important places, but we can work outside our boundaries to engage our neighbors in the delivery of conservation results. In Ontario, there's several programs like the Alternative Land Use Services that have been doing implementing models like this for many years quite successfully. Delivering landscape scale impact in our Great Lakes watershed requires innovation, non-traditional partnerships, unique investment, and thinking outside the box. And the Long Point Coastal Wetlands Phragmites program is an excellent example of innovative collaborative work to achieve collective impact. The project began in 2015 with the establishment of the Long Point Phragmites Action Alliance, which was a group that had a common interest in eradicating Phragmites from the Long Point area. The alliance brought together partners from the agricultural sector, hunting and fishing clubs, cottage associations, municipalities, government, community groups, and environmental organizations to develop an efficient and effective management approach for their ambitious goal. The map shows the extent of Phragmites in the Long Point coastal wet marshes before the program began. Roughly 1,000 or 1,300 hectares of Phragmites was mapped. And with the support and buy-in of many different agencies and organizations, Ontario's first aerial and ground-based application of a water-safe herbicide for the control of Phragmites under an emergency use registration permit from Health Canada began. The mantra of the Phragmites Action Alliance was together we can manage Canada's most invasive plant, and together we did manage Canada's most invasive plant. In the previous slide, I mentioned about 1,300 hectares of Phragmites was mapped at the inception of the project. But if you look in the red circled area here, the amount treated to date far surpasses that at around 1,600 hectares, with close to 400 hectares left to go. The results of the control efforts have been validated through well-designed and careful monitoring programs looking at surface water quality, benthic invertebrates, fish, non-target vegetation, and of course the efficacy of the work at all overall. And for those of you who have traveled to Long Point, you've probably noticed a tremendous change just in your viewscape alone of what you can see now that this tall towering plant has really been removed from much of the coastal wetland environments, as well as sand dunes, beaches, shorelines, and riparian areas as well. In this project, the biggest asset was the community support. The team really worked to leverage community connections. For example, the Long Point Ratepayers Association, which represents cottage owners in the Long Point area, took a strong lead in advertising and organizing public information sessions, renting halls, and talking to their neighbors to build that buy-in and help validate the project. In total, there were 28 coastal landowners involved in the project, including 8 private hunt clubs. So you can really see that many different, typically non-traditional partnerships were formed in order to make this work happen. And that was sort of the first phase of the project, recognizing that a significant investment has been made in the protection and restoration of habitat in the Long Point coastal marshes. An additional program was developed to target Phragmites outbreaks in the Big Creek watershed. Of course, Big Creek drains into the Long Point Inner Bay. It travels through Big Creek Marsh. So it's a constant seed source for those coastal wetlands that many people have diligently worked to control Phragmites in. So while continuing the work in the coastal wetlands is also critical and must be prioritized, the implementation of the Big Creek Plan is happening in tandem. It was launched in 2019 and it started in the lower reaches of the Big Creek watershed, and each year has moved further and further north. There's over 200 participating landowners in the project, and close to 78 properties have had treatment conducted on them. So it's a wonderful success story. The Big Creek Phragmites program is led by a subcommittee of the Long Point Phragmites Action Alliance that represents 15 organizations of diverse and different partners. And we will continue to implement this project for the years to come, hopefully moving past Highway 3, which is that red line you see cutting across the middle of the map up into the northern reaches of the watershed. Of course, none of this work would be possible without the many donors, grantors, and partners that have been involved. The slides presented today really reflect the hard work of my coworkers, colleagues, and many different partners. So although I get the benefit of presenting, I am presenting on behalf of many people who have made these fantastic projects happen. I would like to thank TRCA and ECCC for inviting the Nature Conservancy of Canada to speak today. And for those who spoke before me, I think I've learned quite a bit bit, and there's a lot of really great work happening out there that will help decision making and information gathering as NCC moves forward with developing and updating natural area conservation plans in the Great Lakes watershed.
Thank you so much for the great presentation, Kristen. We'll take a few questions now before we move into our final panel discussion. So Kristen, my first question to you is, with your focus on Southwestern Ontario, are there any unique challenges in your mind to coastal wetland conservation in Southwestern Ontario?
Yeah, that's a great question. I think there's certainly a lot of challenges. As we're seeing rising water levels and more frequent and extreme storm events. I live just north of Long Point, and so they're happening much more often. Not necessarily a unique challenge, but perhaps unique for our time. That's going to really require a lot of collective impact thinking to overcome. Certainly invasive species management, again, maybe not necessarily unique, but with the success of the Phragmites project, of course, one of the follow-up questions is what happens next. I think, when we look at unique challenges, you also need to look at the unique opportunities. And I'm always very encouraged by the results of the Phragmites project and bringing together so many diverse partners. And I think this model can be transitioned to many other different conservation challenges elsewhere in the watershed.
That's great. Thanks for that, Kristen. And you've already alluded to some novel financing tools during your presentation. I wonder if you can elaborate on a few that you're most excited about.
Well, that is a very good question. This is an area that I'm sort of starting to learn a little bit more about, recognizing that there's so much to do, but there's sort of a finite amount of donors and that you can tap to help support some of this work. I guess I'd say I'm quite encouraged by the work of Carolini in Canada and their conservation impact bond. These sort of homegrown local efforts to really take a new approach to conservation financing that recognizes the uniqueness of the areas that it's working in and brings together a lot of diverse partners. So to whoever asked that question, I would encourage you to check out their website and read about the conservation impact bond.
That's great. And again, the same question I've posed to our previous speakers is, how is a Nature Conservancy of Canada working to support Indigenous-led conservation, and whether you can share a few examples of this with us within the Great Lakes region?
Sure, yes. As an organization, NCC is starting to reflect Indigenous engagement in a number of different ways. One of our more recent changes was trying to build in and reflect Indigenous cultural values, historical uses of the land, etc., in our policies, access policies, hunting policies, things like that. Really investing to help support staff like myself that are implementing conservation plans in very specific geographies with sort of the tools to reach out to Indigenous communities. As I mentioned in my presentation, a big focus of our work is restoration, particularly earth moving to create wetlands. So we have been working with local Indigenous communities on consultation engagement around ensuring that those activities don't adversely impact undiscovered cultural artifacts. So we're starting to conduct stage 1 and 2 archaeological assessments before we conduct that work. I would say it's happening in a lot of different ways across the province and across the country, whether it's through joint management agreements or conversations prior to the acquisition and protection of properties. There's a lot of different ways that NCC is working with Indigenous communities, and personally, look forward to expanding that work in Southwestern Ontario.
Thank you for that, Kristen, and very important points. Our last question before the panel discussion is wondering if we can get your reaction to the concept of climate refugia as well, which again are areas that remain relatively buffered from contemporary climate change over time. Is this something that you and others at NCC are looking at in terms of identifying and protecting potential climate refugia areas?
To be honest, that was really my first introduction to the concept in any real depth. And I do think it has a lot of merit and will be quite interesting to examine when we are developing new natural area conservation plans, and in Southwestern Ontario, particularly when we're updating our plans. So it's certainly something to take home to the science team, and I'm quite excited and pleased that this has all been recorded so that it can be shared with staff, as I think it's a great concept.
Wonderful. Thank you for that, Kristen. And thank you again for the great presentation. Now, I would like to invite all of our guest speakers to join us for our final panel discussion before the end of the day. And we'd like to start off with a question we received from the audience from session 2, actually, earlier this week, is whether you can all share some activities that are going on that are aimed at the conservation of more wetland area. Any new conservation activities that you are looking at in terms of protecting more coastal wetland areas. And I think you all touched on this in your presentations, but perhaps if you can summarize any key initiatives that you're excited about in protecting more wetland areas, that would be great. Dan, did you want to go ahead first?
I can, but I'm not going to buy Scott much time. Most of our field programs at Wildlife Conservation Society are based in northern areas in the boreal and part of the Arctic Beringia. So really key biodiversity areas are the main initiative that we're taking around Great Lakes coastal wetlands right now.
That's great. Thanks, Dan. And again, Scott, the question was, are there any new initiatives or a summary of new initiatives in protecting more wetland areas? And in the interest of buying you more time, Scott, we'll go to Kristen next.
Sure. One project that comes to mind, it's a collaborative Green Shovels project to expand Phragmites control across the Great Lakes watershed. So that's something to keep an eye out for.
That's great. Thanks, Kristen. Scott.
Thank you for accommodating me there. So within Parks Canada, we have ambitions to eventually establish more national marine conservation areas in the Great Lakes as part of the 25 by 25, 30 by 30 targets. So look towards that. That would be initiatives on Lakes Erie, Ontario, and Huron. But there's a lot of work to do, relationship with the province and Indigenous communities. So I'm not making a promise here, but the ministers and budgets are certainly interested in that sort of expansion of in-water protection in terms of national marine conservation areas. And also I'd recognize like the initiatives like at the Rouge, like they're restoring the historical wetland areas or bringing back to wetland areas. So there's, even within sites, there's the increasing wetland area.
That's great. Thanks, Scott. Robin, did you want to go next?
Sure. As Dan mentioned, I think key biodiversity areas for us are the main thing we're working on for this. But I will say that that map I showed of some of them around the Great Lakes will continue to grow. And we'll have more concrete work on some of these sites moving forward. So right now, some of them have been scoped as potential key biodiversity areas. But as we continue to work with partners on getting these sites officially nominated, and grow this map, I think that could have a benefit.
That's great. Thanks, Robin. And going to our next question, we already heard from Dan and Robin on this question. So I'll go to Scott, Greg, and Kristen for their responses, is whether there are any tools within the conservation toolbox, including policies, land trust incentives. Are there any tools within the conservation toolbox that you would like to see used more for the conservation and protection of coastal wetlands in Canada? So perhaps I'll go to Greg first.
Sure, thanks for that question. There's certainly challenges in Southern Ontario with regards to applying more conservation tools simply because of the land use, urbanization, and agriculture. It is the breadbasket of Southern Ontario. I see a lot of great work being done up in the north, but despite the land use in Southern Ontario, I still think that there's opportunities there. The concept of refugia is also new to me. I mean, it's not something that I really focused on until I wrote the white paper along with other authors. I think it's really imperative to understand where these areas that wetlands can migrate to, transition to, those corridors and pathways, that may not be very well known, but they exist. And I think it would be a great exercise to map them and work with municipalities to get them put into the official plans and protect them and maintain them, enhance them. So there is space, accommodation space for coastal wetlands. That's just one example that remains largely theoretical at this time. They've done a lot of good work on the eastern seaboard and in the Gulf as well to understand wetland migration. I think we can apply that knowledge here in the Great Lakes. So I'd love to work with partners to do that. That's my initial response.
Thanks, Greg. And I think we'll go to Scott and then Kristen next.
As mentioned in the talk and reinforced by Dan and others, is these protected areas need to be part of, their core protected areas, but then we need to improve connectivity within them, and so establish these corridors. They might not, necessarily be designed for in situ conservation, but they do allow. They're not obstacle courses for species to get across the landscape. So that's important, and then that's often thought of in terms of the land. Increase, our tributaries and watersheds and that sort of thing. I haven't seen a lot of thinking on looking at it from the lake. These coastal wetlands. How are we connecting them coastally? Drawing lines in the water, out in the water, and saying how do we increase connectivity along these systems, and to be able to facilitate post-disturbance recovery. You've got up and down in lake levels, and you may lose species. And how do you allow for colonization along the shoreline and not have too many barriers or invasive species or what have you? So thinking in terms of connectivity on the lake, not simply, and it's important to think up the tributaries as well. I think too is you're seeing this dialogue now on carbon and the role of wetlands and carbon sequestration. We know in seagrass and meadow marshes and saltwater marshes and mangroves even, how much carbon is stored in these marine coastal systems in terms of blue carbon. We don't understand much in terms of the Great Lakes and this potential for being a carbon source, but even owning it, even owning the fact that they may be carbon sources. It's not just all about being a carbon, sequestering and storing carbon, but understanding what the dynamics that are disturbed ones become more carbon sources, or protecting them makes them carbon sinks. So understanding carbon budgets in these coastal systems would be really important. And you're seeing a big initiatives in peatlands up in James Bay and stuff, like Indigenous communities talking about their role in protecting large carbon sources. So getting the science to understand the carbon dynamics in our coastal systems and what we can do to augment and make sure they don't become, because in, say, the marine systems, you can increase methanogenesis and others if you disturb these wetlands. So we don't understand that in the Great Lakes context. Sorry, I rambled.
No, those were great points. Thank you, Scott. Kristen, do you want to go next in terms of any conservation tools that you would like to see used more?
Yeah, sure. I mean, I think I just maybe take a different tact with that answer. We're often overwhelmed these days in the media with climate change, doom stories, loss of habitat, biological crisis. But there's a lot of really good news stories too, and unfortunately just don't get the same type of pickup. And I think public awareness, public buy-in, collaborative work is so key to what we do, and taking this great information and these plans and implementing them and turning them into on-the-ground results. So, and that could drive policy, because the more people buy into the vision, the more support it's going to get. And just overall, I don't think that people really fully understand what they can do on a collective basis to help with some of these challenges. So really, I feel like an emphasis on getting the good news out there, the possibilities out there, and this information in a digestible way is a really, really important tool.
Wonderful. More great points. So thank you for that, Kristen. My next question is directed to Greg, but if anyone would like to chime in, please do give me a signal. So my next question is about the federal budget that was just released yesterday, Greg. I wonder if there was anything that jumped out particularly at you, and recognizing that this may be an unfair question because it just came out yesterday. I did see commitment to expand the Nature Smart Climate Solutions Fund, as well as funding to support the Freshwater Action Plan, the Great Lakes Fishery Commission, and the Canada Water Agency. Just looking for your apolitical reaction to what you liked and what you would like to see more of.
Yeah, thanks for that question, Sharon. The devil is in the details, really. It's written in such a broad way that I honestly haven't had a chance to speak with upper management to see how it really would impact my own work or the work within the Great Lakes Ecosystem Management section and my colleagues. It did speak of a Canada Water Agency, though. So we are nested within that. I think that's a very positive uptake on something as important as the Canada Water Agency. I know that our colleagues have been working on that over the last couple of years now, at 1 year for sure. And as I say, the details aren't really there, but I think that there's some really good potential to continue our work on the Great Lakes and water quality in particular. But hopefully there's some really key messages with regards to habitat and species that we can bring forward through the new budget as well. Climate Smart Solutions, that has already been announced. I think they've had 2 call letters so far. That's being taken care of by the Canadian Wildlife Service. They may have another call letter in the winter. I forget what the time scale is, but it reinforces the importance of coastal wetlands, grasslands, and forests as carbon sinks, and working with the agricultural sector and other sectors to protect those areas and restore them as well, so they can continue to uptake carbon. Yeah, I think it's pretty positive. I honestly don't know the real details at this point in time, and I'm probably unlikely to know them for another couple of weeks. Yeah, thanks.
That's great. Thanks, Greg. And just looking at our other panelists to see if they would like to jump in before we move to the next question. Dan, is that?
I'll just add a little bit there about what's happening globally right now with the post-2020 Global Biodiversity Framework, which is really the Convention on Biodiversity and some of the updates being done to that. We've all heard about the 30 by 30, but the talks that happened in Geneva just a couple of weeks ago are really emphasizing some other really important things around restoration is a key one. And Kristen mentioned that the global decade for ecosystem restoration. So as Canada kind of develops its national biodiversity strategy and action plan in response to whatever comes out of these discussions, which we should know by the fall, I am optimistic there is going to be a greater recognition of the need to restore nature, and a lot of talk globally about kind of bending this curve. Like it's not just about stopping anymore. Like let's try to make things better. I don't think we've ever had a government that has been this supportive of nature conservation, including in the Great Lakes. And it really, I think, is our time to act around conservation and restoration and getting conservation, into the public discourse so people understand the benefits of doing these types of projects. So I would just encourage everybody to really roll up their sleeves in the next few years. And while we have a bit of stability in our federal government, to try to move things forward as quickly as we can.
That's great. Thank you for bringing that in, Dan. And I think that is a perfect segue to our next question about the 30 by 30 commitment is what would you like to see through this commitment realize for coastal wetland conservation and protection, and through a commitment to conserve at least 30% of areas within Canada? How would you like to see that play out in the Great Lakes region? Perhaps we'll start with Greg.
There's large and small coastal wetlands throughout the Great Lakes, and some of the maps that we've shown you really show where the larger ones are. There are so many smaller coastal wetlands as well that are of extreme importance to water quality and biodiversity. I think there's ample opportunity to work with landowners, or wetland owners privately to secure those lands. Ducks Unlimited and NCC are doing a great job so far. I was going to say that a lot of the smaller wetlands are privately owned, and that was supposed to be my segue to that answer. So I think you get the point. There's opportunities out there.
That's great. Thanks, Greg. Scott, did you want to go next?
I can. Well, Dan mentioned it earlier, but I'll reinforce it, is that we look at the quality. It's not just looking at a big number. We make sure that we're protecting the right 30%. And with that said, the Great Lakes have historically been wrapped up in the terrestrial target. So it's, land and inland waters, not part of the marine target. But so I think we have to look at our accounting and make sure that we're protecting freshwater, representative, redundancy, adequately protecting freshwater, and also consider the challenge of accounting for coasts. Like, it's either land or water, and really we know that we're wrestling with this interface all the time. So how can we make sure that we're protecting at least 30 plus or more quality coastal ecosystem in the accounting?
Mm-hmm.
That's great. Thanks, Scott. I did want to go to Dan next, but I'd like to add on another question to Dan is, how do you think what needs to be done to ensure that Canada actually achieves that target? So in addition to what you like to see unfold within the Great Lakes region, is how do you make sure Canada achieves that target?
Okay, I'll start with the last question. Canada will achieve the target. I mean, we're one of the few countries that has huge wild areas in our north, and we can easily achieve 30%. The challenge is making sure that 30% is distributed, and that we are focusing on not just the places that we can easily protect, but the places that we need to protect before they disappear, including some coastal wetlands around the Great Lakes. So I'm less worried about the quantity, except for the fact the government might lower the bar in terms of what we call protected areas, but that's sort of a different discussion. So I think key biodiversity areas and this focus on quality is really important. Like we showed last time, we'll achieve 17%, the numeric target, very easily, but we do need to focus on that quality aspect. In terms of Great Lakes wetlands, kind of going back to that thing about distribution, like, we need to make sure that we are protecting these wetlands everywhere, including urban areas, which might involve some restoration. But I do think a lot about the headwater areas. I mean, if anything makes us think about systems, it's coastal wetlands, because they are connected, into the watersheds. They're connected through migratory birds, and watersheds and some of these like heavy agricultural and urban landscapes. We just need to come up with some kind of solutions to protect habitat areas that are helping to reduce sedimentation, reducing peak flows that are going into these, and doing it in a way where, in some of like these valuable farmlands where it's really hard to carve out these protected areas, we need some new mechanisms to work with the farming community to do that.
Yeah. Wonderful. Thanks, Dan. And I will go to Robin and then Kristen.
I don't have too much to add based on what Dan said, but yeah, I think really just focusing on quality by looking at some of these key biodiversity areas. And hopefully in the next few years, we'll have a really good sense of where these are along the Great Lake wetlands. So this could be a good tool to use to achieve that.
Yeah.
Thanks, Robin. And Kristen?
Yeah, I don't have anything else to add. Totally agree with the conversations around the quality over quantity. I think, one point to add is just a new and sustained investment in keeping up with some of these great initiatives, expanding them out to other areas, sharing those lessons learned.
That's wonderful.
Sharon, one more point. Greg here. Yeah, I should mention that, and Anders has mentioned this as well, we are undertaking a Canadian baseline coastal habitat survey. So that's that coastal fringe along the entire Canadian Great Lakes. We are looking, so we're doing this because it's a benchmark for improvements and for net gain in habitat. So we had to define what net gain would mean. And we define it as an increase in extent, an increase in diversity, an increase or improvement in functionality. And that could be connectivity, et cetera, et cetera. So we have these metrics that have been put in place through the baseline coastal survey, and establishing that benchmark is really imperative because we know where we're starting from. So we can revisit that work in 5 years, let's say, and do the measurement again to determine net gain, hopefully not net loss. And it does include the quantity as well as quality. So I just wanted to make mention of that. That information is going to be made public as well on a geospatial platform through Environment and Climate Change Canada. So we're pretty proud of that work. It's not us alone. We work with the province as well as DFO in terms of the tributary aspect of our work. So stay tuned on that. I would love to have another webinar series just to showcase our coastal habitat survey work in Canada.
For sure. That sounds very interesting, Greg. And in the interest of time, I'll just pose my last question to all of you in a lightning round to end off. What do you think makes for effective conservation in existing protected areas under a changing climate? Perhaps we'll go to Scott first.
Well, there are standards for assessing management effectiveness in protected areas, and I think we could use that rigor and that process to go through and evaluate our protected areas effectively being managed, looking at the IUCN criteria.
Thanks, Scott. Dan, did you want to go next?
Sure. Ramp up monitoring to look for new threats, including new invasive species, and more consideration of a greater ecosystem approach to managing protected areas.
Great. Thanks, Dan. And we'll go to Robin, Kristen, and we'll leave the last word for Greg.
I would say just to try to use some sort of multifaceted approach that includes things like climate change, refugia, biodiversity, ecosystem function, connectivity all together.
Thanks, Robin. And Kristen?
I think focusing on practical and implementable monitoring solutions is the way to go.
Thanks, Kristen. And finally, Greg.
I would say people and process. So people inside and outside of protected areas, all of your stakeholders, the people that these protected areas affect most, Indigenous peoples, of course, included, and processes. And I think Dan or Scott touched on it, but you can't manage in isolation with the broader ecosystem. And Pete Suzak really brought this to a fine point in his talk about natural physical processes operating in the nearshore and the natural transport of sediment, the sinks and the sources, and the natural versus climate-caused erosion, making sure that these really unique geophysical landforms like the sand spits in Lake Erie, for instance, are protected in the long term. And that means making sure that the physical processes that transport and deposit sediments and sand in those areas that, by the way, protect large coastal wetlands are maintained and protected. And it really includes working with agencies and stakeholders and the rights holders as well to make sure that we get this done right.
That's great. Thank you, everyone, for sharing those points. And that brings us to the end of our panel discussion. So thank you to all of our speakers for your excellent presentations today and for staying with us for the excellent panel discussion and for your ongoing work. I would also like to thank our project team, Greg, Anders, and Patrick from ECCC, and Megan, Jessica, and Krista from TRCA for making this webinar possible. And finally, a big thank you to the more than 200 of you who have consistently joined us every day over the course of this webinar series. Your interest and passion about Great Lakes coastal wetlands is really amazing. And thank you to the respondents to our poll as well. We didn't have time to go over the results, but there was overwhelming interest in pursuing further discussions on coastal wetland adaptation resilience, which is great to see. And for questions that we were not able to cover within our time today, we will follow up with speakers for some brief written responses, which we will share along with the presentation slides and webinar recording. And we anticipate that the slides and recording will be available in a couple of weeks following the webinar series. So please keep an eye out for an email. And I would now like to call on Greg to say a few last words and share some upcoming reports and resources.
I'll make it quick. Thank you to all of our speakers. And thank you for putting up with my persistent badgering and cajoling and convincing and pleading to participate in this webinar series. I know that each and every one of you are very busy people with your own work, but I think together we make this discussion much more strong and viable. So thank you so much for all of our speakers over the last 5 days. And thank you to the Coastal Wetland Working Group team within Environment and Climate Change Canada. This was a very novel project in many ways. It involved you, the public, it involved many agencies and First Nations, but it involved 4 branches within Environment and Climate Change Canada that maybe have a history of working in silos, and we broke those silos down. So thank you to my team. Just in closing, we've talked a lot about various aspects of the project, and suffice it to say that there's going to be several large papers, technical papers, and public-friendly papers that will be produced and made available on our website. Of course, they all have to be approved, translated to French, and gone through a process with communications before they're put up on our website, but it's something that we can look forward to. They are very indeed comprehensive, detailed technical reports that I think can inform conservation and adaptation as we move ahead. Thank you. And thank you to you, Sharon, as well as your TRCA compadres, because without you guys, this would not have happened as smoothly as it did.
That's wonderful. Thank you for those closing remarks, Greg. Thank you everyone for joining us, and take care.